this tutorial, I want to show you how to factor a trinomial where the leading coefficient is 1. So if we're looking at something like x squared plus bx plus c. So for this first example, let's go ahead and look at x squared plus 9x plus 14. And we learned today that this is going to factor, since we have a leading coefficient of 1, to the product of two binomials, each that start with x. So x plus or minus something in this binomial and x plus or minus something in this binomial. Because when you do FOIL, you do x times x to get the x squared. And we're not going to see any other x squareds in here because these are just going to be constant terms at the end of each binomial. So the way that we find those constant terms, we have to look at what is the coefficient of x and what is our constant. So our constant is a positive 14. We learned today that we have to find two numbers that multiply together to be the constant, but add to be the coefficient of x. And the way that I figure that out is I usually make a factor table of that constant. So the constant is 14. I know 1 times 14 is 14. I know 2 times 7. And if I needed to, I could also consider negatives. So a negative 1 times a negative 14 is a positive 14. A negative 2 times a negative 7. Now these negatives are going to help us if for the constant, or I'm sorry, the coefficient of x, if this had been a negative number. So if I needed something to add together to be a negative coefficient of x, I would look at this part of my table. But I just need two numbers that multiply to be a positive 14 and add to be a positive 9, which we can see is the 2 and the 7 right here. So this becomes x plus 2 and x plus 7. And it doesn't matter which one you put where. You could have had the x plus 7 first. It doesn't matter. But if I go through and I fill out this with FOIL, or I find out what this product would be, I should get back to the x squared plus 9x plus 14, which I would. We'd have the x times the x for the x squared, a 2x for the inside, a 7x from the outside, and then 2 times 7 gives you 14. Now it gets a little bit more challenging when you have subtraction in that the polynomial instead. So again, we still need numbers that multiply together to be negative 40 but add together to be negative 6. So when I start listing out the factors of negative 40, I know that to get a negative number when you multiply, one of the numbers should be positive and one should be negative. So I still start out just listing all positives and I can work with those afterwards. So I know 1 times 40, 2 times 20, 3 won't work, 4 times 10, 5 times 8, and that's going to be it. So now I have to start thinking about one of these is going to end up being negative. But the negative 6 kind of stands out to me. I can see that there's a difference between 4 and 10 of 6. Now if I want them to add together to be a negative 6, I know that the 10 will have to be the negative number because it's larger. So a negative 10 and a positive 4 is a negative 6. So this is going to factor to be x plus 4 times the quantity x minus 10. So they still multiply together, 4 times negative 10, to be negative 40. But when I add negative 10 and 4, I get negative 6. So again, if I were to go through with FOIL, x times x gets us x squared. A 4 times x is a positive 4x. The x times the negative 10 over here, that's going to be a negative 10x. And then the 4 times the negative 10, that's going to be minus 40. So it simplifies to be x squared minus 6x minus 40. So we do know that this is the correct factored form of the problem.